By the way, I did update this handout yesterday or the day before, but if you don't have the latest version, it's okay. All I did was type this first example I'm going to do, and then which examples y'all are going to do. Hey, y'all. Talking at the same time I'm talking. That's just rude. Practice test 3 is in Momentum, and test 3 is next Wednesday. I'm going to be here at 7:15. Y'all can come whenever you'd like. You could come at 8:45 if you wanted to, but you still have to leave at 9. So I will be here at 7:15. All right, one of the two problems that I want to do with you before I turn you loose on some examples is that one. I wanted to start with a good old polynomial before I jumped on anything harder. And those guidelines right above the example are what I want you to follow and give me on every problem that you do in 4.6. You're going to have 5 problems for homework tonight. You're going to have 5 problems for homework Monday. Each problem is probably going to take you a page. You can have at most 1 of these on the test. It's just too much for you to do 3 of those on the test. So here's what I'm going to be looking for. On every problem, I want you to do it neatly. I want you to number it and letter it just like I have, because I'm going to grade some of these and I don't want to go blind trying to figure out where what is on your paper. I want you to use words for what it is that you're finding. So step 1, first thing I want you to do is find the domain. And I want you to write the word domain. What's the domain of a polynomial function? Negative infinity to infinity, or you could use fancy R. Either one. Number 2, find the intercepts. Actually, I could break this into an A and a B part, but I won't because I didn't on my paper. Let's find the y-intercept and then the x-intercept if it's not terrible to find. If it's terrible to find, I won't worry about it. But y-intercept's always easy to find. You just do what? Let x be 0, and I can see that would give me what? If I let all those x's be 0, everything would be gone but the 5. I don't care if you write the ordered pair 0, 5 or the number 5, as long as you graph it on the y-axis. The x-intercept, how do you find the x-intercept? I don't think I want to do that. It won't factor by grouping. There's something called the possible rational zeros theorem. Do you remember that guy? I could list my factors of 5 over my factors of 1, find my possible rational zeros. Here's my promise to you on the test. If you can't fairly easily find the x-intercept, then I won't ask you for the x-intercept. You're going to have to use the possible rational zeros theorem to find it. I just won't put that on the test. So let's not do that right now. How about that? We can do it. We don't want to do it. I think the rest of the problems that I've seen so far in 4.6, it's not so bad to find the x-intercept. You'll be able to do it. Third, I want you to find the asymptotes. Do polynomial functions have asymptotes? No. What are the only, show me with your hands. What's the only 4 things a polynomial function can do on the ends? X squared, negative x squared, negative or positive x cubed, and negative x cubed. No asymptotes. That's the only 4 things a polynomial function can look like. All right. 4 is where the work comes in. And not so much on a polynomial function, but 4 has to do with all of your calculus. You got to find both derivatives, find what makes them 0 or an undefined, put them on a number line, determine whether they're positive and negative, and then you can answer parts A through G. So the first derivative of that function, 4x cubed minus 24x squared plus 36x minus 16. How am I going to find the critical numbers of a third-degree polynomial that I don't think will factor by grouping? If I factor 4x out of the first two, that'll leave me at x minus 6. No, that's not going to factor by grouping. How can I find the critical numbers? How could I have found the x-intercepts but chose not to? I could use the rational zeros theorem. I don't think I'll have to, because if I can just find the first 0 of this, then I can use synthetic division to get it down from cubic to quadratic, and I can go from there. I can either factor further or I can use quadratic formula. I only have to find 1 0, one critical number before that's manageable. So how do you find 1 0? That would be helpful. Factoring out a GCF is always a good idea. Already looks a little more manageable. Oh, wouldn't that be, let's see. Oh, 4 times 6 is not 36, is it? I can do calculus, I just can't multiply. Okay, so any suggestions about how to find a 0 or our first critical number? How about yes? And try something. If you were going to try something, what would you try first? Really? Why? You can just see. Did God whisper 4 to somebody? Okay, 4 would not be my first thought. It might turn out to be a 0. It would not be my first thought. My first thought, well, would be, let's see if 1 works. If it doesn't work, I might try -1. And I just pray that I don't have to go too far before I find my first 0. I think, does 1 work? 1 minus 6 is -5, plus 9 is 4, 4 minus 4 is 0. So we found the first 0. Not scientifically, not methodically, but we just guessed and we tried, and I wouldn't give you one that you couldn't find that first 0 pretty quickly. So if we see that 1 is a 0 of that function, that means I can do synthetic division with 1 in the box, and I better get what for a remainder? I better get 0 for a remainder, or else I'm wrong about 1 being a 0 of that derivative. Out beside the box, those coefficients, 1, -6, 9, -4. That allows me to factor my derivative into what linear factor times what quadratic factor. If I have +1 in the box, I'm dividing by x minus 1, and my quadratic factor is, which just happens to be something I can factor further. All right, so I had to use a trick, synthetic division, to get it down into something manageable. But now I can see that the derivative is this. Please check your factoring. I don't want you to make a mistake right here and the whole rest of the problem be wrong. Yes, sir. I could divide both sides by 4. When I set that equal to 0, I could either divide both sides by 4, or I could set 4 equal to 0 and say, well, that doesn't give you a solution. All right, so that derivative is x minus 1 squared times x minus 4. You don't have to write it that way. The previous line's fine too. So what are my critical numbers? 1 and what? 1 and 4. And because they are critical numbers of the first derivative, that means they're possible what? Possible relative extrema. I'm just making myself notes because I think in words. I just made my note. That's possible relative extreme. I'm going to go ahead and find the second derivative and what makes it 0 while I'm differentiating. Where would be the easiest place to take, what form of the first derivative would be the easiest place to find the second derivative? Up here. Yes, sir. Either this or that. Either one's absolutely fine. If you want to use this one, then you keep up with the 4 and you just factor this would be 3, not factor, differentiate. You differentiate that would be 3x squared minus 12x plus 9. And then I'm looking for what makes that equal 0. I can factor a 3 out of that, multiply the 3 times the 4 that I already have outside. It gives me 12 times x squared minus 4x plus 3. And thankfully that will factor. So what makes the second derivative 0? 3 and 1, and those are possible what? Possible inflection points. Hey, 1 is either a relative extrema or a point of inflection. I don't know which. I'll find out which. Possible inflection point are at 1 and 3. So I'm ready to look at the sign of the derivatives. And here's how I'm going to write my number line. I'm going to find the sign of the second derivative and the sign of the first derivative all on the same number line. I'm going to put all, let's see, I had found 3 possible somethings, 1, 4, and 3. So I'm going to put 1, 3, and 4 all on that number line. If you want to make 2 separate number lines, that's absolutely okay. What's your favorite number to the left of 1? 0. Let's find the signs of the first derivative first. Here's my first derivative. I noticed that no matter what x is, this first term can't be negative. So really, I only care about the sign of the second term. Does that make sense? All right. If I let x be 0, the second term is going to be negative. If I let x be 2, the second term is going to be negative. If I let x be 3.5, the second term is going to be negative. And if I let x be 5, the sign of the second term is going to be positive. All right, let's do the same thing with the second derivative. Here's my second derivative right here. My favorite number to the left of 1 is 0. If I put 0 into the second derivative, what's going to be the sign of my answer? It's going to be a negative times a negative is a positive. What if I put in a 2? Negative times a positive is a negative. What if I put in a 3.5? Positive times positive is a positive, and what if I put in a 5? Positive times positive is positive. So now I'm looking at this, because I want my parts A, B, C, D, E, F, G to match up here. A part, I want the increasing intervals. To find the intervals over which the function is increasing, do I look at the first derivative or the second derivative? First derivative, and I'm looking specifically where the first derivative is which sign? Positive, so 4 to infinity. Where's the function decreasing? Negative infinity up to 4. C is relative max. Is there anywhere that function changes from increasing to decreasing? No. It changes from decreasing to increasing, but that's a min. So there is no relative max. The relative min is going to be at 4, where the function changed from decreasing to increasing. And I'm just going to tell you that when I plugged 4 into the original function, just to save us a minute, when I plugged in a 4, I got a negative 27. That's just a minute on a calculator. And when I say when I plugged in 4, where do I mean I plugged the 4? The original function. All right, E part, where is the function concave up? What derivative should I be looking at? Second derivative, and specifically where the second derivative is positive. So it's concave up from negative infinity up into 1. And then it's positive again from 3 to infinity. Where's the function concave down? Where the second derivative is negative, and that's just 1 to 3. Is that as far as my alphabet goes? No, there's a G part, points of inflection. Are there any questions so far? Folks who are asking? Why? That a problem can take a page?
So much.
And I write very, very small, and it still takes me a page.
Yeah.
Is there an inflection point? How would I locate an inflection point by looking at that sign chart? Where the concavity changes in either direction. So the concavity changes at 1 and the concavity changes at 3. There are 2 inflection points. I would have to get the y values for them, but I have done that already. And what did I get? 1, 0, and 3, negative 16. Yes, sir. Yes, yes. It turns out we found one of the x-intercepts. It's an inflection point. All right. Step 5 is the graph. Try to get it on the same page. If I have any asymptotes, are there any questions back there, guys, guys? Any questions? Good? Okay.
I was routing when you were talking about the inflection point.
Yes. The inflection point is where the concavity changes,
Okay.
and the concavity changes at 1 and at 3. Second derivative. I'm looking for something to throw at him, but I don't see anything that wouldn't hurt. I'm gonna bring you a tennis ball next time. Okay. If I had any asymptotes, I would graph those first. I don't. If I have any specific points, I will graph those next. Where are my specific points starting at the top? My y-intercept is 5. What's the next point you see? Next point I see is relative mean. Relative mean is 4, -27. Maybe I'll just count. Oh, shoot, I've already counted by 1s up there. I am not going to count all the way to -27. I'm going to draw me a tick mark way down there and label it -27. Which means my graph may not be to scale, but that's okay. As long as I've labeled where that is, that's okay. 4, -27 is a relative mean. 1, 0 is an inflection point. 3, -16. 3, -16 might be about here. 3, -16 is an inflection point as well. Is that all the single points that I have identified? If I just connect those 4 points, I'm going to guess this looks like x cubed. It's x to the 4th. It can't look like x cubed. So let's figure out what's going on. It's increasing from 4 to infinity. And let me check something else. It's concave. The concavity is the part that it's hard for me to work in. It's concave up from 3 to infinity and increasing from 4 to infinity. Concave up from 3 to infinity, increasing 4 to infinity. I suggest doing this in pencil, by the way. Strongly suggest doing this in pencil. It's decreasing from -infinity to 4. So I'm not drawing this yet, but I can see that that's going to be where it's coming downhill, right there. I just got to work the concavity into that. It's concave up from 3 to infinity. I have that. Concave down from 1 to 3. How can it be concave down from 1 to 3, but yet it's decreasing? Draw what you think it would be on your paper. Concave down and decreasing from here to here. And then it's concave up from -infinity to 1. From all the way over here to here, it's concave up. Can you make that piece look concave up? How did I think we might get 5 examples done today? I don't know. Now I'm wondering if I can get both examples that I had chosen for myself done. Gonna go for it. Any questions on this? I strongly advise you to work in pencil because there's going to be some erasing. If you don't work in pencil, then you copy over and make it neat. I don't care which one you do. I hate pencil, so I copy over and make it neat. I am not turning in chicken scratch to a professor. just because I'm too lazy to recopy your work in pencil. Yes, sir.
So what is all on this?
The practice test is in momentum.
Okay.
It's 3.5, 6, 7, and 4, 1 through 6.
That was
Practice test is in momentum. All right, let's do another one. This one actually is not quite as long. Maybe. Hey folks, I seriously need you to stop bursting into chatter every time I pause for a breath. If you have a question, ask me. But otherwise, be quiet because this is just intense. Takes a lot of focus here. All right, number 10 is negative x squared minus 4x minus 7 over x plus 3. I want you to label number 1, domain, and before I just jump right in there, no, I can go ahead and say that the domain is everything except for what? -3. And I'm pretty sure that at -3, what will happen? That there will be a vertical asymptote. The only way there would not be a vertical asymptote at -3 would be if what? If that function, if that numerator would factor in such a way that I could cancel out the x plus 3 or -3 would still not be in the domain of the original function because the original function had x plus 3 in the denominator. But if I could cancel out that x plus 3, then rather than having a vertical asymptote at -3, what would I have? A hole in the graph. You can tell that doesn't happen, that numerator is primed. All right, number 2. What about the intercepts? The y-intercept. How do you find it? Let x be 0. I can see that y would be -7/3. What about x-intercepts? You would have to use the quadratic formula. Without writing down the quadratic formula, tell me what goes under the radical. B squared minus 4ac. Can you tell me whether b squared minus 4ac would be positive or negative? B squared would be 16. No, yeah, b squared would be 16 minus, what would 4ac be? 28, and 16 minus 28 is negative. What does that tell you about x-intercepts? The answer you would get from the quadratic formula is an imaginary number. An imaginary number can't be an x-intercept, so there are no x-intercepts. I'm not just saying we can't find them. I'm saying there is none, because if you set that numerator equal to 0, you would only get imaginary solutions. All right, number 3, is there a vertical asymptote? Is there? Yeah, since I can't cancel out that x plus 3 in the denominator, the vertical asymptote is x equals -3. Make sure you're giving me an equation, not a number. -3 is not a vertical asymptote. -3 is a number. X equals -3 is a vertical asymptote. What about horizontal asymptote? If the numerator is higher degree than the denominator, then, well, is there a horizontal? No. There's no horizontal because the degree of the numerator is higher than the degree of the denominator. But because the degree of the numerator is only 1 higher than the degree of the denominator, there's a slant asymptote. And how do I find it? If the denominator was a monomial, I would divide that into 3 terms and get the linear part. But because it's a binomial and I can use synthetic division, I'll use synthetic division with -3 in the box and the coefficients -1, -4, -7 out beside that box. Yes, sir. What did I do? I just lost my negative? Yep, you're right. -3 times -1 is +3. So that's -1 times -3 is +3. -7 plus 3 is -4. I will accept that much marking out on your paper. That in my book is still neat. I've seen stuff from a few people that isn't neat. So what's my slant asymptote? Y equals -x. These are the coefficients of my quotient. -1x minus 1. So I have one vertical asymptote and one slant asymptote. That's number 3. Number 4 starts the calculus. And I think, just for time's sake, just to get this problem done, I'm going to go ahead and tell you what I got for the first and second derivatives. That's what I got for the first derivative. So what are the critical numbers? Or I'm just going to go ahead and label them possible relative extrema. Where are my possible relative extrema? -1, -5, -3? No, because why? -3 is not in the domain of the original function. So my only 2 critical numbers, my only 2 possible relative extrema are -1 and -5. And then I'm going to tell you what I got for the second derivative. Oops. -8 over x plus 3 cubed. One of those rare instances where the derivative kept getting simpler instead of uglier. Second derivative have any critical numbers? Only -3, and -3 is not in the domain of the original function. What does that tell me about inflection points? No inflection points. So I'm ready to think about the sign of the second derivative and the first derivative. What numbers do I need on my number line? You need that vertical asymptote there so you don't just skip right over it. I don't remember what section that was, 4.2 I think, said put your discontinuities and your critical numbers on a number line. So here's -5, -3, -1. And this is how I tell myself, hey, there's a vertical asymptote there. All right, let's find the sign of the first derivative in each interval, and then we'll find the sign of the second derivative in each interval. First derivative to the left of -5 is -6. Everybody look up for a second. I'm trying to make this as easy on myself as I can. If I realize the denominator is always positive, I'm not even gonna worry about it. I'm just looking at the numerator and saying -6 would give me a negative times a negative times a negative, which would be a negative. I don't care what it is, I just want to know its sign. What about a -4? I'd have a negative times a positive, and that would give me a positive. What about -2? That would be a negative times a negative times a positive would be a, okay, why do I have so few people talking? Have I made a mistake? Or did y'all get shy all of a sudden? Let's try this -2 again. Negative, negative, positive, positive. And then my favorite number to the right of -1 is 0. 0 would give me negative, positive, positive, which is a negative. Let's do the same thing for the second derivative. I really don't have to use 4 test points here. I can see that the second derivative is only going to change signs where? At -3. And so if I put in, I could use the -5 if I wanted to. If I put in a -5, I'd have a negative over a negative would give me a positive. That means positive both sides there. And then what if I put in a -2? I'd have a negative over a positive is a negative. So I'm ready for my alphabet. This function is increasing where? Can I say solid -5 to -1? No, because it's split up by that vertical asymptote. I have to say -5 to -3, and then from -3 to -1. And then B, it's decreasing. Where? -infinity to -5 and -1 to infinity. C part is relative max. Is there a relative max? Wherever the function goes from increasing to decreasing, and that's at -1. -1, and I'll just tell you when I put -1 into the original function, I got -2 for y. Is there a relative min? Where the function goes from decreasing to increasing at -5. -5. When I put -5 into the function, I got +6. Which brought to mind a very interesting question. How can there be a max at -2 and a min at 6 if 6 is bigger than -2? I don't get that. Hang on one second. Think about it. How's that possible? All right, tell me what you think. That's not the reason. That's not what I was thinking as the reason that your min can be higher than your max. How is that even possible? Because they're relative. That's not absolute max and absolute min, or that wouldn't make sense. But this -2 can be higher than what's on either side of it, and this 6 can be lower than what's on either side of it. All right, E part is concave up. Where's the function concave up? Wherever second derivative is positive, negative infinity up to -3. Where's the function concave down? -3 to infinity, wherever the second degree is negative. Second derivative is negative. G, what's the inflection point? Is there an inflection point? No, we decided that way up here when we saw there was nothing that made the derivative 0, second derivative 0. All right. There's the actual size of my writing. Put it on a graph. I always graph my asymptotes first. I have a vertical asymptote at -3. And I have a slant asymptote, y equals -x minus 1. That has a y-intercept of -1 and a slope down 1 to the right 1. Those aren't points on my graph. Those are points on my asymptote. And come on, straight line. Ooh, one of my better straight line days. Now, what points do we have? The y-intercept is a little below -2. What other points do we have? Relative max is -1, -2. Relative min is -5, 4, 5. +6. This could be a little bit tricky without graph paper. Because I've already done it, I know that -5, 6 is in this part right here. That'd be much easier to do with graph paper, and precisely you could tell it's a little bit above the slant asymptote, not a little bit below. Any other points? Nope, that's all my points. So decreasing from -infinity to -5, decreasing but concave up. Gotta sneeze. I never have just one. I did. Okay. Decreasing -infinity to -5, but concave up to -3, concave up to this vertical asymptote. So decreasing, something's bugging me, decreasing, oh, -5's right here. It's decreasing up to that point, and then it's increasing, and it's concave up. And then from -3 to -1, it's increasing. Here's -1 right here. Increasing and concave down. At -1, there's a relative max. It starts decreasing and concave down, approaching that asymptote. Wow. 2 problems per hour. I know. That's why you do not have 1 through 47 odd for homework. Day 1, there's 5 problems. Yes, look at your homework because it may be different than what you printed. 3, 7, 9, 11, and 17. And then start working on that practice test. Basically, you should not have a life this weekend or any weekend before a calculus test. Is there a football game Friday night? No?
No.
Calculus all weekend! Yay! Basketball. Basketball. It's common, but there's one more whole week before Thanksgiving. Just one.
I know.
Basketball is so much better. Allie, you know, I like cheerleading. Okay, it's 2 basketball games, just basketball is better. Well, yeah, and basketball as a sport. Nah. Yeah. I don't like basketball. I wish I still played basketball. That was fun.
Yes, right there. Mm-hmm. Yep, just stick it in that pile. I forgot my stapler today, but I'll get it in my office. Hello, Miss Samantha. Hello, Miss Megan. Yes, my dear.
In our problems for homework last night,
Which were
Number-
word problems. Okay, I was just catching up with myself. It's word problems. Okay.
number 9,
I didn't know it was reverse.
I forgot to stop recording.
yeah, so